Hello everybody, I'm Catherine and I will be your physics master teacher. So today we will be solving some questions from KCET for the chapters Electrostatics and Current Electricity. So have you all started your preparations for KCET?
Yes, ma'am is audible. Yes. Okay, 1 second, ma'am. Yes, students, is ma'am audible? Please let her know in the chat box. Come on, quickly. Yes, ma'am's first class, so ma'am is going to be a little camera conscious. So you people have to be nice to her, okay? So ma'am, you can see the chat there,
Yes.
okay? They're all telling you hi. And yes, you can ask them the questions and they will give you the answer as well, okay? Yes. Clear? Okay. Yes, ma'am is going to start the class. Today we are going to do
Electrostatics and Current Electricity.
Okay, they are the high weightage chapters of
Yes.
KCET, right?
Yes.
Yes. Okay. Ready? Puts a lot of fire emojis in the chat, and whenever ma'am is, not very audible, just let her know. Okay? Clear?
Yes.
Yes. Okay. All the best, ma'am.
Thank
okay?
you, thank
yes,
you.
ma'am. You can go to the next slide there. Yes.
Yeah, right.
Perfect. Okay?
Okay.
Yes.
Okay, so the two chapters that we are going to deal today, electrostatics and current electricity, they are of quite high weightage compared to the others. So that's why we're going to start with those today. So I believe all of you have just finished your exams and you might have studied electrostatics. So first we will start with some formulas. So all these formulas, they are derived from certain equations. So if you want the derivation, I can do a class on that. Right now, we will just look at the formulas and solve questions based on that. Okay, so the first formula that we need for this session is the Coulomb's law. So Coulomb's law is basically for, it is to find out the force between two charges. Okay, that is, okay, so if you have two charges, the two charges, one second, the thickness, okay, Q, all right, okay. So if you have two charges, these two charges by default have a force between them. So that force is what we are going to define by Coulomb's law. So Coulomb's law states that the force between two charges depends on the distance between them. So here we are going to assume that the distance is r. Okay, so the distance between both of my charges are r. So the charges are q1 and q2. Now, I'm also going to include a constant. So before that, let's say the force is proportional to this force is inversely proportional to the square of the distance between the charges. So since the distance is r, I will write it as 1 by r square. Now this force is also okay. Okay, the force is also directly proportional to the product of both the charges. Now, when I combine these two, I get the formula as force is proportional to Q1, Q2 and the distance is directly proportional to the product of the charges, inversely proportional to the square of the distance between them. Now, I can't do mathematics or problems with proportionality. I always need an equal to. So to put an equal to, what I'll do is I'll replace this proportionality with an equal to along with a constant. So let's say the constant is K. So I put a constant and the formula becomes divided by r square. So this is Coulomb's law. Now this k also needs some value, right? Only if you know what k is, you can do problems. And our ultimate aim for KCET is to solve problems. So let's look at what k is. K actually is this. So it is 1 by 4 pi epsilon naught. So 4 is a number, pi is a constant, and epsilon naught gives you the free space. Now this 1 by 4 pi epsilon naught or k has a certain value which you have to know. So for your questions, you are supposed to know the value, and the value is 9 into 10 raised to 9. So we will solve questions based on this formula, and then it will be a little more clear to you. So this is the first formula that we will be using in this chapter to solve questions. Now, yeah, I hope it's clear to you. Please complete the class in half an hour. Okay. Okay. So the next formula is the formula for electric field. So electric field, please excuse me, I'm just getting used to this board. So electric field E is the force that we discussed in the previous slide. That force divided by the charge that's acting. So we already know that force is what? K QQ by R square. Now I will put this Q also here, divided by Q. So this part is from the force that we learned in the previous slide. Force, this is the formula for force. So K QQ by R square, Q and Q cancels. So what remains? K Q by R square. This is the formula for electric field. Here also k is the same, 1 by 4 pi epsilon naught, which is 9 times 10 raised to 9. Another formula that you need to know is for electric field itself, but when it is in the axial position. So axial position would mean, so I have two charges, okay, and I have a third charge which is along the same line. This is what is called axial position. If all the charges are along the same line, then you get a formula like this. So this formula you actually derive using certain steps, which I can explain to you if you want. You can just tell me in the this one. Okay. If you know the theory, then we can move forward. So this is the formula for axial. This is the formula for equatorial. So for potential, it is KQ by R. So since I see people tell me okay, so let's go to the problems. Since you already know the formulas, we'll go to the problems. Okay, so first question. Two charges, the charges are plus 3 Coulomb and minus 3 Coulomb. They are placed at a distance 6 centimeter apart. You have to find out the force between them. So you have two charges. Okay, I can give you some time, you can solve it. After that, I'll solve it. I'll just show you how it is. So there are two charges. They are at plus 3, minus 3, and they are at 6 centimeters apart. You have to find out the force between them. Can you solve it quickly and tell me the solution? Okay, some of you are asking me to revise the formula. Some of you are asking me to do problems. So okay, let's solve this question now. I don't see any responses. So this question is based on the formula that we just revised, the Coulomb's law formula. F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. So this is based on that formula. So let's just solve it. So the formula is here. So 1 by 4 pi epsilon naught, I already said you have to learn the formula, learn the value. So the value is 9 into 10 raised to 9. And then Q1 and Q2, you had two charges. So the charges were +3 and -3. And you can see it was in microcoulombs. So you have to convert it into coulombs, which is the SI unit. That is why it is multiplied with 10 raised to -6. Okay, so F is 9 into 10 raised to 9 times 3 into 10 raised to -6. I will just put it as square. It is just 2 times 3 into 10 raised to -6 into 3 into 10 raised to -6 divided by what is r square, the distance, 6 centimeters. 6 centimeters should also be converted into meters because centimeter is not the SI unit of length. Whenever you do questions, all the units should be in their SI units. So that's why 6 centimeters would become 0.06 meters. Can you try to solve it? Are you getting it? Can you tell me in the comments if you've understood this question so we can move on to the next one? Yes, okay. So someone's, Kiran hasn't understood. Suchi. Ramya, okay, so I think someone said, okay, yeah. Okay, so I believe most of you have understood it. No calculator, ma'am. Yeah, you will have to be very good at math for your KCET. You wouldn't get calculators. So the trick is to just first solve the powers. Solve the power separately, solve the numbers separately. So for example, you do 9 into this number, 9 into 9 divided by 3.6. You do this and then you multiply it with the powers. So here the first power is 10 raised to 9. The next power is 10 raised to -12. And then in the denominator, can you see this? 10 raised to -3. Can you see it there? Yeah, there it's clear, I think. So powers you can solve. You know the basic trigonometry formula. A raised to m into a raised to n is a raised to m plus n. And then a raised to m divided by a raised to n is a raised to m minus n. So you do 9 plus 12 minus 3. 9 plus -12 minus 3. So this is a very basic problem. I think this is clear. Okay, let's move on to the next question. Okay, yeah. Anyways, let's move on to the next question. So now you have two charges. The first charge is plus q and the next charge is minus q. So plus q and minus q are placed at a distance 2d. So this distance is 2d. Now we have to find out, See, we know the formula to find out the force between the two charges. F is equal to Q1 Q2 by 1 by 4 pi epsilon naught Q1 Q2 by R square. But here the question is to find out the net force on a third charge. So not just two charges, we have one more charge. We have to find out the net force on a third charge exactly at the midpoint. So I have to find out the force on this charge because of plus Q and minus Q. So anybody has any idea on how to do this? If you know the answer, you can write down the option in the comment section. So you have to find out the force because of the pink colored charge at the center. So let's see. Anybody? B, okay. Someone, Amulya has answered B. Anybody else? Okay, Honest Girl also says it's B. Ramya Sri says it's B. Okay, so many people says it's B. Yes. So the answer here, okay, is not B. It is A. Anybody said A? Not really. Okay, so let's see how it is A. So as I mentioned, you have two charges, plus Q and minus Q, and then a third charge at the center. So both of these, so there is a force here, there is another force here as well. So we will take it section by section. So first we will find out the force on Q because of Q. We will find out the force between these two, and then we will find out the force between these two. So we know the formula is 1 by 4 pi epsilon naught Q by d square. So in the question they have said 2d, right? The distance between the two, it is mentioned as 2d. So obviously what would the distance between these two be? It should be half of 2d. Since the distance between both the green charges are 2d, the distance from here to here should be d. So this would be d. So now our aim is to find out the force between the pink charge and the green charge placed at a distance d. Is that clear? Fonts are small. Okay. I'm not sure on, can I make it bigger? No. Okay. I will write it on the sides for those who cannot see. So the force between the charges would be 1 by 4 pi epsilon naught, the first charge into the second charge. So one is the pink one is the green one, divided by the distance, which is d square. Now same thing happens on the other side. So you might be wondering, one charge is plus Q, one charge is minus Q. Why I am not putting plus Q and minus Q here? Because we are only looking at the magnitude. Plus Q minus Q gives us direction. So here we only look at the magnitude, so you can ignore the direction. So on the second part, which is here, again we will do the same. The force between Q and Q. How much would that be? Again, 1 by 4 pi epsilon naught Q by d square. So that is this one. So the force because of the plus charge to the midpoint and the negative charge to the midpoint will have the same value. But you can see they're both in opposite directions. One is positive, one is negative. So that's when the sign comes into picture. So negative sign and positive sign represents two different directions. So since they are in opposite directions and they have the same magnitude, won't they be zero? You agree with me? Yes, both. No, F1 equals F1 in magnitude. But when it comes to direction, F1 equals minus, F1 equals F2. They both have the same values, but they are in opposite directions. One is positive, the other is negative. Hence, they cancel. So, since they have the same values, but they are in opposite directions, they cancel, you get 0. If you've all understood, can you all give me a thumbs up so I know what's happening there? Yes, Rahul has understood. Thank you, Rahul. Others? Okay, the honest girl has given me thumbs up and fires. Yes, very good. Kashif, yes. Both have the same force but in opposite direction, yes. Okay, since most of you have understood, I believe, let's move on to the next question. So these are all questions based on the first formula that we learned, Coulomb's law. Next, now you should be able to do this question because this is also similar. Again, force between two protons. So that is another value that you need to know. You need to know the charge of a proton. Anybody knows the charge of a proton? If you don't, you should learn it today. We will learn it now. So just like you know 1 by 4 pi epsilon 0 is 9 into 10 raised to 9, you should know the charge of a proton as well. And here you have, again, same figure, but here you have two protons. And they're separated by a distance of 1 Fermi. So in the question itself, they've given you 1 Fermi is 10 raised to minus 15 meters. As I mentioned, whenever you do a question, you have to convert the units into SI units. See, Fermi is not an SI unit of length. The SI unit of length is meters. So Fermi should be converted into meters. So let's do it. Yes, very good. 1.6 into 10 raised to minus 19. Who is that? Keshav. Yes, Keshav has answered. It's very good. 1.6 into 10 raised to minus. So same thing. This you should be able to do it by yourself. The formula is F is equal to K. K times Q1 Q2 by R square. K is 9 into 10 raised to 9. Q1 and Q2 are 1.6 into 10 raised to minus 19. That is the charge of a proton. You have to know that. Okay. 1.6 into 10 raised to minus 19 divided by 1 Fermi, which is 10 raised to minus 15 meters. So it is R square. So you square it. Can you quickly solve it and see if you're getting 23? Okay. So I'll also do it with you. Let's take the numbers first. So the first number is 9. The first number, we're ignoring the powers, only the numbers. First number is 9. We have taken that. Next one is 1.6. Okay. And then into, we'll take the powers now. The first power, okay, I don't have space there. Let me write it here. Okay, 9 times 1.6. So these are the only numbers. Now we'll put the powers. This you can solve. 9 into 1.6. Quickly, people, solve it. Okay, some people have, the answer is option B. It's there here. So 9 into 1.6 times, let's take the powers. We'll take all these three powers. So 10 raised to 9 into 10 raised to minus 38, 10 raised to minus 30. How did I get minus 30? It's minus 15 square. Remember, you might have learned this in maths. A raised to m into a raised to n would be a raised to m into n. Okay. So A raised to 15 square is a raised to minus 30. So how will we solve it? Sorry, there is a square here as well. It's 1.6 square. 1.6 into 1.6. Okay, so 9 into 1.6 into 1.6 would be 23. And then 23 into the powers. So you have 9 minus 38, and then this negative sign, this negative 30 will go up, so it would become plus.
So, ma'am, 1 second. The students are telling something in the chat. I think some answers. 230.
Yeah, 23. Yes, the answer is 23. Very good.
1 second, students. Just 1 second. Is it visible now? Yeah?
Yes.
Okay. Can you see it from top?
Yes.
Okay.
So some of you are getting 230. How are you getting 230? So 9 into 1.6 into 1.6 should be 23. I think you should check your calculation. And when you solve these, 9 minus 38 plus 30, how much is it? What I am getting is 1. So this would be 23 into, okay, yes, 10 raised to yes, I understand. It's 23 into 10 raised to 1. So the answer has to be this one. There is some error in the presentation. So this, yes, Pratish, it's 230. Yes, Kasif, it's 230. So when you multiply, you can always multiply the power separately and then the number separately. I hope you've all understood this question. It's again similar to the question for, you just have to simplify. Okay. All right, let's move on to the next question. So the next question is a little different but similar. So you have 4 charges. Okay, the charges are plus Q1, plus 2Q, plus Q and minus 2Q. They're all placed on the corners of a square AB. Can you? Yeah, they're all placed on the corners of a square ABCD. So let's draw a diagram. So I will put a square, okay, and I will name the square ABCD. So that's the question. and on all four corners there are 4 charges. So I have already also written that here. So these are the 4 charges that are going to be present on all 4 corners. So let's put them all. At A it is plus Q, at B it is minus 2Q, and at C it is plus Q, and D is minus 2Q. Now in the question it also says that we have to find out the force on a unit positive charge kept at the center. So there are 4 charges on 4 corners of a square, and you have to find out the charge that's kept at the center. So the charge is positive, that's given to you in the question. So this charge here is a positive charge. So in this box, the question is to find out in which direction the force is going to be. So let's draw 2 diagonals. Okay, so we will evaluate the forces on both the sides. So first we will evaluate the forces on AC, and then we will evaluate the forces on DB. Okay, let's do that. Yes. A. Yes. Option A. Yes, very good, girls. I mean, sorry, not girl. I mean, Kashif, good. Vaishali, yes. Okay, so many people have already answered, but for those who are still struggling, we will just quickly do it. So, since we all know like charges repel, unlike charges attract. So look at this diagonal. There is a positive charge, there is a positive charge, there's a positive charge. None of them like each other. So what happens? They all repel. So this positive charge would repel, this one would also repel, and since they're repelling in the opposite direction, they would cancel out. So O does not experience any force in this direction. Now look at the other diagonal. Here you have a negative charge, positive charge, negative charge. So positive, negative, 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 positive, negative. Since they are different charges, unlike charges attract, so there is a force along the diagonal VT, which is the question. The question was to find out the force along, in which direction O experiences a force, and it's clearly BD because on the other arm they cancel out. Unlike like charges repel. Yes, I think this question is also clear. This is a simple question. There's not a lot of mathematics. It's just your understanding. So shall we move on to the next question? Anybody has any doubts? Yes, good. The answer is option A. Very good, Prajwal. Sam, Berlin, good. Art World, hi. Nidhi also has answered A, very good. Bomika, good. So yes, so I think all of you have got A. Oh, very good. Prajwal has also found out the force. Good. Okay, so I can see some no ma'am. What do you mean you've not understood? I think it's clear. Can we move on to the next question? Yeah, let's move on to the next question. Next question is again using Coulomb force, but here so one thing I want to know, the formula 1 by 4 pi epsilon 0 q1 q2 by r square is for 2 forces that are in free space. They're not in any medium, they're not inside anything, they're free. Okay, so they're not depending on anything, any medium, anything that's in between them. Only their charges and the force between them. There's no medium. But here in this question, 2 charges q1 and q2 are placed, same thing, q1, q2, they're placed at a distance r, they're placed at a distance r apart. Okay, no meant for no doubt. Okay. Yeah, so there are 2 charges, they're placed at a distance r, but here the only difference is a dielectric medium of relative permittivity K is introduced between them. So these charges are not in free space. They are kept somewhere, they're kept inside a medium which has a dielectric constant. So we will have to slightly alter Coulomb's force. Let's see how we do that. It's not such a big deal. It's a very simple thing. So wait, before you see the solution, okay, I'll write it here. So force is 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the formula that we know. But now this epsilon naught is the permittivity of free space. But in this question, the charges are not in free space. So this epsilon naught is affected or is added with a dielectric. Let's put the dielectric as K. So our new epsilon, this would be epsilon, which is the relative permittivity, not of free space. So an extra dielectric is added. So the same thing should be added in the formula as well. So let's add that extra term in the formula. So this K should be added in the formula also, because this is a force between the charges inside a medium. So when this K is, since the K is extra, this whole term is for force only. So now we can write this F dash to be equal to this whole force divided by K, which is this formula. So when the dielectric was added, what happened? The force reduced by a factor of K. Is this clear? Yes, vacuum and permittivity, free space is the same, that you don't need K, but here you need the extra dielectric. Since it's a dielectric medium, you need the extra permittivity term, which is K. So if the question says in vacuum or in free space, you can just use the direct Coulomb's law formula. So the option is yes, very good. Option B, decreases by a factor of K. Yes, Varsha, good. Akash, yes, good. Okay, you want me to be more fast. All right. Yes, next question. So you've definitely learned gravitational force. I think in your first PU, you learn about gravitational force. So this is a question where you need to use both the formulas. The first formula for electrostatic force, which we just revised, 1 by 4 pi epsilon 0. How it is decrease? Yes, I can say how it's increasing or decreasing. See, imagine, I can put some numbers and show it to you. So imagine force is 10. Okay. Force is 10 and K is 5. Okay. So initially your force is 10, but when it is inside a dielectric, the dielectric is 5. So what happens? This would become 10 by 5, which would become 2. So for the first force without the dielectric, these are just random values. Okay, I'm just putting values because someone has asked me to explain how it's decreasing. That's why this is not related to the question. It is related, but these values are not from the question. So imagine your force without a dielectric was 10. When I add a dielectric, I have to divide it by K. K is 5. So see, the force reduced to 2. So without the dielectric, the force was 10. With the dielectric, the force is reduced to 2. So that's how it is decreasing, because of the dielectric. That is just for, understanding. Okay, let's go back to our question that we were discussing. So we need electrostatic force and gravitational force. Here the charges are 2 electrons. So I have 2 electrons. So let's start by writing the formulas. What is the formula for the first part? The formula is 1 by 4 pi epsilon 0. Instead of Q1, Q2, here it's written E square because the charges are E. So the first charge is E, the second charge is also E. E into E is E square. So you have E square. The distance between them is R square. So you have R square. Now this, I think you've learned last year. the formula for universal gravitational constant, it is Gmm by r square, which is Gm square by r square. Now what we will do is we will divide these two. How it's decreasing? Okay, we will just finish this and go back to the previous question if you want to know how it's decreasing. So we will divide these two. We will divide what all? Coulomb's force and Newton's law of gravitation. We will divide those two equations. So let's see. So So 1 by 4 pi epsilon naught E square by R square divided by Gm square by R square. This is what we do. This is basically F electrostatic divided by F gravitational. Now when we divide this, what happens? The R square terms will cancel. So we know the value of this. How much is it? So this is 9 into 10 raised to 9 into, we also know the charge of an electron. The charge of a proton we learned 1.6 into 10 raised to minus 19. It's the same. Charge of an electron is also the same. You know, an atom is neutral, so it has to have the same charge, the electrons and the protons. So 1.6 into 10 raised to minus 19. Since there are two charges, I will put a square. Divided by the value of G also you should learn. So the value of G is not gravity, it is universal gravitational constant, and the value of G is 6.67 into 10 raised to minus 11. Yes. Okay, and then you just 6.67 into 10 raised to minus 11 into, again, mass of the charge would be 9 into 10 raised to minus 31 square. When you do the math, you get the answer. Have you all gotten option A? Yes, Kashif, it's option A. Yes, I will give you a list of formulas. I will share it with you. I'll find out on how I can share it with you. I have a list of formulas. I can give it to you. Yes, I can give you. Okay. Yeah. So I'm going at this pace so that, you know, all of us understand. So for some of you, it might be fast. For some of you, it might be slow. But right now, we will just go in this pace. We will pick up pace. Okay. Yes, formulas for each question. When I'm doing the question, I am giving you the formulas. You can also take a sheet, you know, when you're sitting in physics class, you can take another sheet, keep it beside you. Every time you solve a problem, you write down that formula there. So by the time we finish this, by the time we finish all of these, you will have a set of formulas that you have made by yourself. So you will have a formula sheet of your own. I will give you one as well, but then you can do that as well. Okay. Let's go to the next question. Yeah, this question you have to do it because similar, not similar, but yeah, same formula. So you have 2 point charges. You have to find out what happens when the distance is doubled. So for these questions, you should be quick. You shouldn't be writing all the formulas and then solving. You should be quick. So what will you do here? The distance is doubled. So what happens? Initially, F was KQQ by R square. So I am not writing 1 by 4 pi epsilon 0 because I can just write it as K. And here you don't need to do any math. So I'll just write it as K. So the question is, the distance is doubled. So what happens to R square? R square doubles. 6D. Okay, everybody's saying D. Okay, let's see. So R square doubles. So what happens? It becomes 2r square. So 2r the whole square. The only change is the distance becomes r to 2r. So this becomes, let's go back here, k q by 2r square. Which is kq by 4r square. This much is your force. So it would be F by 4. Which option is that? Yeah, option A. So here the only thing that you have to do is the distance is double. So you write down the formula for force. Instead of the distance as r, you write as 2r. Because in the question they say the distance is double. So instead of r, you write 2r. And then what happens? Since you're squaring it, it becomes 4r square. So there's an extra term 4. So that's why your answer is F by 4. For these questions, you shouldn't be doing all these steps. You should be able to instantly answer it. I'm just doing it for you to understand. But you should keep practicing questions such that for these questions, you don't have to write steps. Yes, good, good, good. Yes, it is A. Candy, good. Prajwal, yes. Kashif, yes, good, good. It's A. Okay. Let's move on to the next question. Yes, next is a different question. So here, this also you have learned in your electrostatics chapter about a conducting spherical shell. I'm sure all of you have learned that. If you've learned for your exams, you might have learned that. So if you have a charge Q and it is there on a conducting spherical shell, you have to find out where the charge distributes. So imagine I have a shell like this, okay, and I have charges here. These charges can pass through the shell and reach the other side like this. They can do this as well. So see, imagine charges are lazy and they don't want to dig into a conductor. So what they do, they just flow through the surface and they reach the bottom. So they just do this. They do not pass through the conductor. So that's why here the solution will be B, on the outer surface only.
Yes. How is it going, ma?
It's going well. I think they're all answering.
Yeah, they're all very smart, no?
Yes, yes.
Oh, very smart people you people have become. Guys, why are you not liking the video? Let me know that. Is there a reason to not like and subscribe the video? Huh? Only ma'am, we want content and then we will go home, ma'am. Howda? Like ಮಾಡಿ ವಿಡಿಯೋನ ಸ್ವಲ್ಪ ಮ್ಯಾಮಿಗೆ ಸ್ವಲ್ಪ ಅಪ್ರಿಷಿಯೇಷನ್ ಕೊಡ್ಬೇಕಲ್ವಾ ಸೊ ವಿಡಿಯೋನ ಲೈಕ್ ಮಾಡಿ ಆಮೇಲೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ ಚಾನಲ್ನ ಓಕೆ ಮ್ಯಾಮ್ ಇನ್ನೂ ಸ್ವಲ್ಪ ಲೈಕ್ ಮ್ಯಾಮ್ ಇವತ್ತು ಸಿಸ್ಟಮ್ ಲೈಕ್ ಸ್ಟುಡಿಯೋದಲ್ಲಿ ಬಂದಿಲ್ಲ ಮ್ಯಾಮ್ ಸೊ ಮ್ಯಾಮಿಗೆ ಸ್ವಲ್ಪ ಸಿಸ್ಟಮ್ ಗೊತ್ತಿಲ್ಲ ಲೈಕ್ ಎಲ್ಲಿ ಮೆಸೇಜಸ್ ಬರುತ್ತೆ ಎಷ್ಟು ದೊಡ್ಡದಾಗಿ ಕಾಣಿಸುತ್ತೆ ಅದಕ್ಕೆ ಮ್ಯಾಮ್ ಫುಲ್ ಟೈಮ್ ಮುಂದೆ ಹೋಗ್ತಾ ಇತ್ತು ಬಿಕಾಸ್ ಮ್ಯಾಮ್ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ವಿ ಆರ್ ಆಲ್ ಓಲ್ಡ್ ಸ್ಟೂಡೆಂಟ್ ಓಕೆ ಸೊ ಅದಕ್ಕೆ ಇವಾಗ ಸೈಜ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ್ದೀನಿ ಸೊ ದಟ್ ಮ್ಯಾಮ್ ಕೆನ್ ಯು ನೋ ಸಿ ಕ್ಲಿಯರ್ಲಿ ಅಂಡರ್ಸ್ಟುಡ್ ಸೊ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಇಶ್ಯೂಸ್ ಇರುತ್ತೆ ಅದು ನಮ್ಮ ಲೈಫಲ್ಲೆಲ್ಲ ಇರುತ್ತೆ ಅಲ್ವಾ ಸ್ಟಾರ್ಟಿಂಗ್ ಟ್ರಬಲ್ ವಿಲ್ ಬಿ ದೇರ್ ಫಾರ್ ಆಲ್ ಆಫ್ ಅಸ್ but we learn from that, right? But I think you all, if you're enjoying, I saw a lot constant. Okay, ma'am's name without knowing ma'am's name. Catherine ma'am.
Yes, Catherine.
A could also be correct. Everything can be correct. I don't know. Okay, continue, ma'am. Ma'am, please drink water and hydrate yourself.
Yes, yes, thank you. Okay. Yeah, sorry for looking there. As ma'am said, I can't see properly. So yes, inside the conductor there are no charges. It is 0. The electric field is 0 because the charges cancel out and you get 0. So all of the charges reside on the surface. That's why the option is, sorry, yeah, okay, it's here. On the outer surface only. Yes, Chandan, it's B. Very good. Okay, let's move on to the next question. Yeah. So two charges, plus 4q and minus q. So right now there's a difference. One is plus 4q and the other is minus q. You don't have to bother about that. It's all the same. Plus 4q minus q, they are placed at a distance d. We have to find out the position where the electric field is 0. So let's first make a diagram. So whenever you get a question, if you make a diagram, it helps you understand. It helps you see what you have to find, you know. Yeah, we will cover the syllabus. Okay, so this is plus 4q, this is minus q, they are placed at a distance d. So at some point on this line, the electric field is 0. So I will just put a rough, so let's say it is at this point. Okay, roughly I am saying it is going to be at this point. So I have to find exactly where this point is going to be. Okay, thank you all. Some of you have subscribed and liked, and Santur, I will drink water. Yes. So let's do that. So now what we are going to do is, we will take this distance as x. So how much would this distance be? The total length is d. If this part is x, then this distance will be d minus x. So the charge, the central charge is at a distance x and d minus x from both the charges. Now you just have to use Coulomb's law on both the charges. Coulomb's charge for plus 4q and minus q. So let's do that. So for plus 4q, it will be first 1 by 4 pi epsilon naught. The charge is plus 4 q divided by, okay, one more thing. Here we are not going to find out force, we are going to find out electric field. Okay, please note that the formula for force and field is different. The formula for electric field is only 1 by 4 pi epsilon 0 q by r square. There is no q because electric field is F by Q. So whatever force we have, you divide it by Q. So that's why you have only one Q. Okay, I hope that's clear to all of you. Let's move on. Yeah, so because of the plus 4Q, the electric field is 1 by 4 pi epsilon naught plus 4Q by, what was the distance? It was x, right? Yeah, this distance, it's x. So this is x square. Next, E for Q will be 1 by 4 pi epsilon naught Q by, here the distance between these two is d minus x. So it would be d minus x square. Now since both of these are the same, I will just cancel them out. Now we have to find out the point where the electric field is 0. That means electric field from both the sides should be the same at that particular point. That's how it becomes 0. So both of these have to be equal at that particular point. So we will equate these two. So that's how you get 4q by x square is equal to q by d minus x square. Is that clear? Now it's just basic math. Now let's do the math. Q and Q cancels. So 4d minus x square is equal to x square. So 4 into d square plus x square minus 2xd is equal to x square. 4d square plus 4x square minus 8xd is equal to x square. This goes here. So you get 4d square plus 4x square minus x square is 3. 3x square minus 8xt is equal to 0. Now quickly, this is of a quadratic form. Something's happening there. Okay, this formula is of the form of a quadratic equation. So it's just of the form ax square plus bx plus c is equal to 0. So what is a here? A is 3, b is minus 8, c is 4. So you can just substitute it in the quadratic form and get the solution. Are you doing it? Are you getting it? It's happening in the chat box. Okay, Kashiv says he's got it. Yeah, from here it's just basic math. If you just solve it, you will get x as 2d and x as 2d by 3. And let's look at the options. In our options, we have 2d by 3. So this is going to be the answer. Okay, yes, okay, since you've all understood, we'll move on to the next question. Next question is related to work done. So the work done in moving a charge q between 2 points in an electric field. So here also no force, electric field. So if you have an electric field and you have 2 charges, we have to find out the work done in moving a charge between 2 points. So let's say work done is basically q times your potential. So if you're bringing a charge from somewhere else, does it say in an electric field? Okay, that's all. This is just a direct question. Work done is q times v, and v is what? Your electric field into d. So substituting that here, what would it become? Q E D. So the answer would be, where is the option? Yeah, option A. Yes. This is just a basic formula, a basic question. Let's move on to more complicated questions. Okay, so we did a similar question for force, to find out the force at the midpoint. This question is to find out the electric field at the midpoint. So you have again 2 charges plus q minus q. You have to find out the electric field at the midpoint. So the electric field will be affected because of plus q and minus q. So again, you have to use the formula. Okay, one more thing that you need to know here. Both of these charges together, they're placed at a distance d. So that means this distance would be d by 2. This distance would also be d by 2. So let's apply the formula. The formula for electric field is E is equal to 1 by 4 pi epsilon naught q by d by 2 square. That is what is written here. So that becomes d square by 4, which is this. So 4 goes to the numerator. So this would become 1 by 4 pi epsilon naught 4q by d square. Okay, so because of one charge, what is this? Okay, so yeah, because of plus q, the electric field at the center is what you found out. So the same thing would be there because of minus q as well. But because they're both in the same direction, because plus q will be in this direction, minus q will also be in this direction. So since they're going to be in the same direction, you add them. But the question is to find out the magnitude of electric field at the midpoint. So the midpoint, at the midpoint, because of one charge is enough. So you can just stop with that. And the answer would be, which option is this? Yeah, this one. So here I am not doing it for both the charges because they've only asked me to find out the value of electric field at the midpoint. So one charge is more than enough. You don't have to add them. I mean, yes, you can add them. If you add them, you will get 8q, but you don't need that because the question is to find out the electric field at the midpoint because of any one charge. So that's why it is option C. Then if is due to both, no. Yes, the electric field is due to both. But it's the same, it's in the same direction. So you just have to equate one part because the other one is just 2e because they're both in the same direction. So you just E plus E. So when you do 2e, you get that. So the fields would basically add up. Okay. So let's move on to the next question. Okay, any doubts? Is it clear? Yes, if you find it for both the charges, you will get, what happens? The total electric field is electric field because of plus q plus the electric field because of minus q, which is 8q divided by 4 pi epsilon naught d square. Now if you get confused, what you can do is you can just go to the options. You don't have an option with 8q. So that means they've only asked you for one charge. I mean, both the charges are affected, but at the midpoint, the effect on both the sides are the same. On this side, you have a 1 by 4 pi epsilon naught 4q by d square. On this side also, you have a 1 by 4 pi epsilon naught 4q by d square. So both these together you get the total, but you only need to find out how much the electric field is affected. Board is blur. I think that's because I am not that great at drawing. So the two charges, midpoint, this much, the field is this much, the field is this. See, you need not add or subtract. You just have to find out the electric field because of plus q and E. Okay. It's going to be the same as the electric field because of minus q and E, because both of these are the same charges. They're just in they're just positive and negative, and they're going to act in the same direction. So it's just going to be the same. If you subtract, you get 0, but why do you have to subtract? You don't have to subtract. You just have to find out. So there are two components. Both of these, if you add, you will get the total electric field, but in the question, you only have to write one part. Let's move forward. Okay, next question. The work done in bringing a charge from infinity to a point at a distance r from a charge q. So let's say there are two charges. You are bringing another charge from infinity, which is far away. Okay, you are bringing that here. So let's see what happens. Oh. Okay. So we've already discussed that the work done is Q times V. And you've learned V is 1 by 4 pi epsilon 0 Q by R. So if you have an equation sheet next to you, you can write down the next equation, which is potential. Electric potential is 1 by 4 pi epsilon naught Q by R. And then you just have to substitute both these formulas. You will get the answer. This is just a direct question. 4Q pi epsilon naught R. Which option is that? QQ, option A, right? Yeah, I think the answer option A. This is just a direct question. You will have this in your books, you know, the formula to bring a charge from infinity. So if you want me to do all these formulas, I can do them in a different class. So this class is for solving problems, so we will just quickly solve questions. Next is capacitance. So you have two capacitors of capacitance 4 microfarad and 6 microfarad. They are connected in series. What is the formula for capacitors connected in series? You just have to find out the total. This is a very easy question. You have to do it in seconds. You just have to add them. So 1 by C, the total capacitance is basically the sum of individual capacitance. So in the question it is 4 and 6, and since they're both in microfarad, when you subtract them, you will get the answer also in microfarad when you add them. So you need not convert them into farad. Yes, very good, very good. Who's answered? Just an email. What kind of an ID is that? Yes, B. Yes, good, Prajwal. That's the formula. So you will get the answer as B. Quickly, students. Yes, B, B. Vaishali, good, it's B. Yes. Yes. Okay, this is a very simple question. It's just the basics of capacitance. Shall we move on to the next question? Yes, all of you, shall we move on to the next question? Yes, Sanika, it's B. Okay. Let's move on. Next question is related to dipoles. What is dipole? If you have two charges on a straight line and the charges are opposite, you have a dipole. So dipole is placed in a uniform electric field at an angle theta. This is also a very direct question. You should be able to tell me the answer. What is the answer? Quickly. Can I know the answer, please? B, B, B. Prajwal says it's A. Okay. Others, Chandan says it's B. Okay. Yes, BA, BA. The answer is B. It is PE sine theta. Okay, next question. We have an electric dipole of length 2a. So let's say you have an electric dipole and the total length of the dipole is 2a. Yes, good, it's B. That was a very direct question. That's why I didn't explain anything. It's the derivation for torque. Please practice tough questions. Yes, we will move on to tough questions. So since this is my first class, I wanted to, keep it not light. I have tough questions. We will move on to tough questions. So an electric dipole of length 2. I didn't know all of you were so smart. Next class I will come back with very tough questions. The length between the two is 2a. It's placed in an electric field E equals kx. Dipole is along the x-axis. What is the net force acting on it? Anybody knows how to solve it? Yes, can I get some answers? Anybody knows how to solve this one? How do you do it? Okay, let's do it. So we know the formula for force on a charge is given by F is equal to QE. Okay, this is the formula that we've been learning in all the classes. Now we have two charges, right? We have two charges. The first charge is plus Q and the second charge is minus Q. Okay. Is this clear? Net force by Q1. So what is there in the question? In the question it says the electric field is EKX. It's placed at a distance 2a as well. So the positive charge plus Q is placed as x equal to a, and let's say minus Q is placed at x equals minus a. So since the electric field is E equals kx, so for the plus charge it would be k plus a, and for the negative charge it would be k of minus a. Now what is this one? We know F, where is that? Yeah, here. We have found, we've learned the formula F equals QE. And we also know, because it's given, this is from the question, it's given in the question. It's given in the question, E is kx. So for a plus charge, E would be, I will take it as ka and k of minus a. Now what I will do, I will substitute E here. So that is how I get F is equal to, it was QE, instead of E I will put it as KA1. This is for the positive charge. Similarly for the negative charge, I will put E as minus KA. Here this is plus KA, this is minus KA. Is this visible? Okay. Now I will add the two forces, so it becomes minus Q KA plus Q KA, which is 0. Are you able to understand? Yes, Vaishali, it's 0. Good. Others? It's So this is very simple. In the question they have given you the electric field is E equals kx. So on the plus charge and the negative charge. So here I take the charge to be K times A plus, this is K and minus A. And then I substitute that in this formula and then I add the forces. That's all. Yes, is it clear? If it's clear, can you all give me a thumbs up quickly so we can move on to the next question? Yes, yes. Yes, I am here, Gautam. Yes, yes. No, this session will not be for 4 hours. The session will end soon. What is the time now? It's 6:20. In another 20-25 minutes, we will wind up the session. Okay. Kiran, class duration, you all want to go see the match? You don't have to, okay. Prajwal asks, why do I have to always assume it's plus Q and minus Q? That's because it's a dipole. Yes, so many thumbs up. Okay, so let's move on to the next question. Okay. Pragnya, got it, ma'am. Thank you. Okay. Hi, Aradhya. Yes, let's move on to the next question. My wire is stuck. So here you have 2 point charges, Q1 and Q2. They're placed 10 centimeter apart. You have to calculate the electric field intensity at the midpoint. This I will not solve. You have to solve. So there is plus 3, minus 3. You have to find out the electric field at the center. Quickly do it. I will give you a minute. Quickly. Yes, yes. Thank you. You can all give me a like if you like the class. Yes. So find out. What is the formula? You just have to find out the electric field at the midpoint. And the charges are plus 3 microcoulomb and minus 3. Come on. Okay, Gautam says it's option A. Option A. Okay. How many of you say it's option A? Sanika also says it's option A. Let's look at the answer. Very good. Good job. It's option A. Yes, Chinna, Praknya, Gautam, Jyoti. It's not Bhumika. Yes, it's A. So the answer is option A. This is very simple. We've discussed so many questions like that. So, you just have to do this. E is equal to KQ by R square. K is 9.9 into 10 raised to 9. Q is 3 into 10 raised to minus 6. Because it's micro, you have to convert. You have to write 10 raised to minus 6 divided by 0.05 square. Now you just multiply it with 2 because there are 2 charges on both the sides and you need the total electric field. Okay. Good. Let's move on. Yes, very good. So many people have answered. Yes, Geeta, what's your doubt? So, yeah, this is the question. Let's move on to the next question. Separated by a... See, for this question, you have to find out the electric field intensity at the center. Now, the next question, again, you have 2 charges, but you have to find out the electric field at a point P, which is located at a distance of 10 centimeter from dipole along its axial line. So if these are the charges, the other one is kept at a distance of 10 centimeter. So along the axial line means straight along the line of the charges. So let's do it. So here you need to know another formula for electric field at an axial point. If you have a formula sheet next to you, you can write down the next formula of electrostatics. E equals 1 by 4 pi epsilon naught 2p by r cube. So even if you want to know how this formula came, we can do a class where I can derive this to you. If you want, you can just let me know in the chats. So we have to use this formula here. P is the momentum. And momentum is given by the formula Q times 2A, which is basically charge times distance. So this also you learn. There are derivations for all these formulas. If you just see them like this, and if you've not done the derivation, you might not understand. But right now, since this is a problem solving class, we'll look at only the problems. If you want to know how these formulas are, how these formulas come, we can do another session for that. So now it's pretty straightforward, right? You have to use this formula. P here, you get it from this formula. And all the other terms are there. Quickly, can you solve it? Yes, the answer is B. For those of you who've already finished it. Gautam, Prajwal, Geeta, yes, Shina, B. Good, good, good. So many of you are solving it. Very good, very good. Yes, quickly, others. Let's finish it fast. So P would be, how much was your charge? 3 microcoulomb. So 3 into 10 raised to minus 6 into 2 times the distance, which is 6. So one more thing that you need to know here is the separation between this is, between the two charges is 2A. So is it given 6 centimeter? Yeah. So this 6 centimeter is 2A. So you have to use that here. So whenever there are dipoles, it's always separated by a distance of 2A. That is done for the easiness of doing derivations. So if you've done the derivations for this, you'll realize why it is 2A. Yes, the answer is B. Very good. Pratish. It is B. So first you have to find out P. This is 2A. A is 2A is 6. Okay, did I write A here? No, yeah, 2A is 6. A is not 6, 2A is 6. For dipoles, the force length between the charges are always 2A. Yes, formula sheet I will give you in the next class. Okay, so those who have not solved this can do it. Meanwhile, we'll have a break for 5 minutes. You can all just go drink water and please do come back, okay? We will solve some more tough questions when you come back. Please do come back. We'll go for a 5-minute break. So those of you who have not finished this can finish this in the meantime. If you have any doubts, you can ask me as well.
going up. Nails are not there, no. Sound. I think we are audible, ma'am. Students, are you audible? Yes, yes, yes. Quickly, let us know in the chat. Bega heli. Students, if you want to meet us, right? If you want to meet Gopika ma'am, if you want to meet Shreyas sir, if you want to meet us, and Catherine ma'am also, we have a one-day workshop on 30th of this month, right? More than Tariq there in JP Nagar, the Vedantu Centrally, right? So if you want to be part of it, you will see a link in the description. Our description link na click maadi, register maadi ivatti kuda, because we can hardly take 20 more or 30 more students aste. More than 50 students have already registered. One small classroom ಇದೆ ಆ ಸ್ಮಾಲ್ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ವಿ ಕ್ಯಾನ್ ಹಾರ್ಡ್ಲಿ ಟೇಕ್ 20 to 30 more students. ಸೊ ಬೇಗ ರಿಜಿಸ್ಟರ್ ಮಾಡಿ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಅಲ್ಲಿ ಹೋಗಿ ಕ್ಲಿಕ್ ಮಾಡಿ ಲಿಂಕ್ ನ ರಿಜಿಸ್ಟರ್ ಮಾಡಿ ಈಗಲೇ. ನಾನು ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀರಾ? ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ಮಾಡೋದಾ?
ಥ್ಯಾಂಕ್ ಯು. Okay, so let's continue. Yes, so you can all go to the description box and register so you can meet all your favorite teachers. So let's continue. I hope you all have finished this and gotten the answer. Let's continue. So we will finish the class in another 20 minutes. Don't worry, you will not miss your match, okay? You can all go for your match after this. So yeah, next question. Here you have a parallel plate capacitor and it has a capacitance of 10 microfarad. Now, the separation between the plates is doubled and the space between them is filled with a dielectric medium. So whenever you see dielectric medium, remember there is a medium. So it's not the formula that you use, you have to add a term. So you have to find out the capacitance. So what is the basic formula for capacitance? Let's look at that. So the basic formula, so if you have your equation sheet next to you, you can write down the next formula, which is the formula for capacitance, which is C is equal to epsilon naught A by D. This is the basic formula for finding capacitance. When you're in free space, when there's no medium in between, when you're in free space, this is the basic formula for capacitance. C is equal to epsilon naught A by D. But in this question, you can see in the question itself, it says that there is a dielectric medium. So I have to modify this formula. I have to add another term, which is epsilon R. Epsilon R represents my dielectric medium. And then it's just substitution. What will you do? Let's say, what are the numbers? 10 pico, okay, it's 10 picofarad. And the dielectric material, dielectric constant is 5. So this value is 5. Another thing, the separation distance is doubled. So D becomes 2D. So this becomes 2D. So capacitance basically becomes epsilon naught A5 times D into 2. These two terms are added on because the distance is double and there is a dielectric. So this much is your capacitance. So let's put this as C prime. So C prime would be, I will put this as C. C into 5 by 2. And C is given to you as 10 picofarad in the question. Simple. You don't have to do a lot of math. You just have to know the first basic formula, epsilon naught A by D. This is 10. This is given to you and then it's changed in with respect to a dielectric and an extra increase in length. So that is the 5 by 2. So this 5 by 2 is added to the capacitance. That's all. Is this clear? Let's go. The option is option C. If you've all understood this, can you all give me a thumbs up? Yes, Vaishali, very good. It's option C. So if you, as I've told you, keep a sheet next to you. So you write down all the equations as you do. So in your equation sheet, now you have one more equation. You actually have two equations. This is the capacitance in free space and this is the capacitance when there is a dielectric. Let me write it neatly for those of you who want to write it down. Epsilon r by d. For JEE also you will have similar questions, but a little more. We will have to practice more. We will do that in the coming classes. So yes, I see lots of thumbs ups and option C. Okay, let's move on to the next question. Okay, so here you have two conducting spheres of charges plus q and minus q, separated at a distance much larger than their diameters. They are brought into contact and then separated again to the original distance. What is the electrostatic force of separation? Okay, let's see. Anybody has any idea? I'll give you like 10 seconds to look at the question and then we will discuss. Okay, let's move on to the solution. So this is a very simple question. See, conducting spheres. So conducting spheres conduct charges. So the charges redistribute equally. So each sphere will have a charge of 0. So since it's plus q and minus q, they will be 0. So if the charges are 0, what will the force be? The force will also be 0. So the answer is D. See, this question looks complicated and you have lots of complicated options, but it's very easy because you have two charges. Let's see. Yeah. Two identical. D, yes, Gautam. Yes, Praknya, it's D. Very good. Okay. So it's because these conducting spheres have opposite charges. So when when two opposite charges come together, and since they're conducting spheres, they redistribute and you get 0. If charge is 0, will there be a force? See, for a force to occur, you need some charge. Charge is basically the driving, what do you say? It drives the force. It creates the force. Distribution happens when they come to contact. Okay, Pradeep, yes. Okay, good. Let's move on to the next question. Is this the next question? Yes. Okay, we will finish in another 10 minutes. Few more questions. Come on. Everybody, let's do it. Okay, so a point charge Q is placed at the center of a spherical conducting shell of inner radius R1 and outer radius R2. You have to find out the electric field. Okay, let's do it. So this is also similar to the previous question. So the charge Q at the center and the charge minus Q on the inner surface and plus Q on the outer surface. So as I already mentioned, if you have a conductor, charges are always present on the surface of the conductor. Inside the conductor, the charges are 0. So here the question is, at point Q, inner radius R1, electric field in the region R1, which is basically inside, right? Yes. So inside, in the region where R1 less than R less than R2, it will be 0. That is why, yes, Gautam and Shivan, yes, the answer is B. There is no charge inside a spherical conductor. Let's move on to the next question. This is the question that we finished. Okay, so this is the next question. Okay, this is an interesting question. Let's see. So you have a spherical sphere of radius R encloses a charge Q and all that. What is it? Radius is doubled. What happens to the electric flux? Okay, so we have to find out how electric flux is changing. Let's see. But what is the formula that relates charge and radius in electric flux and all that, it is the Gauss law. So Gauss law is phi equals Q by epsilon. Flux is given by Q by epsilon, charge and permittivity of free space. So in this question, if the radius is doubled, does it actually change the flux? Because the formula for flux is Q by epsilon. Where is radius here? So it is independent of radius. So obviously the answer should be remains the same. So in your equation sheet, you can write down the next formula, which is the Gauss law. Phi is equal to Q by epsilon naught. So even if the question changes to radius is 8 times or 10 times, it does not matter, because in our equation there is no radius. So however the radius changes, our electric flux is not going to change. So this was a question for you to understand the concept of Gauss law as well. Yes, Anirudh, Pragnya, Gautam. Yes, yes, good, good, good. It is C. Okay, let's move on. This is similar. Let's move on to a different question. Okay, let's look at this question. So a parallel plate capacitor is charged to a potential V. Okay, capacitor is charged to a potential V and then disconnected. If the separation between the plates, so the separation between the plates is doubled, the separation between the plates is doubled, what happens to the energy? This is the question. So we know what is the formula for energy and capacitance. So we know the formula, E is equal to half Q square by C. So those who have your equation sheet, you can write down the next formula. This is the formula of energy and capacitance. E is half Q square by C. So in our question, what is doubled? The distance is doubled, right? Let's look at the question. Capacitor, and this, if the separation between the plates is doubled, what happens to the energy? Okay, any idea on how to do this? Can I get the answer? Yes, becomes half. Someone has answered. Pratnya, very good. Yes, yes, it becomes half. So what happens is the capacitance, the initial capacitance changes to C by 2. C by 2. So what happens? U is equal to Q square by 2C with a half. So you can see this much is your capacitance. So this is basically U by 2. There is an extra 2 here. So that is why it becomes half. Yes, no, it's option B. Becomes half. Is this fine? So you can write down in your equation sheet, you can write down the next formula. Where did we go?
How many more questions are there now?
We can do 1 or 2. So since we have only 5 more minutes and there are so many more questions, you I'll give you this PDF. I'll send it to you on Telegram. The solutions are also there, so you can work it out. And if you have doubts, you can always get back to us. So we will just solve one more question and then end the class.
So difficult question. Take a difficult question.
Okay, let's not move on to current electricity. We'll finish off with this. Okay, so last question. So you have a charge of 5 microcoulomb and it's moved from a point of a potential VA to a potential VB. So we have to find out the work done. So you are moving the charge from a potential of 100 volts to a potential of 50 volts. Okay, so the amount of work done to move the charge from VA to VB is what we are going to find out. So I think if you have written an equation sheet, in your equation sheet you will have the formula W equals QV. But right now V is moving. So initially it is like, the starting point to this point. So from here you're taking the charge to another point. So the difference would be, so this V would become VA minus VB, because it is between two potentials. You're actually bringing it between two potentials. Charging is over, Gautam. Yes, I'm finishing it fast. Last question. Okay. So what happens? So W would be Q. What is your Q? Q is 5 microcoulombs. So 5 into 10 raised to minus 6 coulombs. Into VA is 100, VB is 50. 100 minus 50. So W would be 100 minus 50 is 50. 5 into 10 raised to minus 6. So we just have to do 5 into 5, which is 25. And then put a 0. See, 5 into 50 is 250 into 10 raised to, how much was it? Minus 6. So which option is it? Which option is it? It is option A. Let's see if it's option A. Yes, it's option A. Very good. Yes. Yes, yes. Pranav is right. This V is delta V. Yes, it is the change in voltage. Very good. Thank you for noticing. So this V is your delta V. It is the change in voltage. So that means the charge work is done and the charge is moved from a potential VA to VB. So the amount of work done is given by this. So we know work done and energy are similar. That is why both of them have the same unit, joules. See, when you're doing work, you're basically transferring some energy. So whenever work is done, energy is always transferred. So I think we will wind up with that. I have more questions of current electricity as well, which we can discuss in the next class. I will also send you this PDF where you can look into the questions and the answers. All the solutions are there. I've put the solutions also so that you can refer later. When you refer, see, I know my handwriting is not that good, so you can look at this and understand. So I think we will wind up with that. So in the next class, we will discuss on current electricity, and if there's anything that you want me to teach or any lesson that you want me to take on, you can just let me in the chat. Pranav wants 5 more questions. I'll give you this PDF in your Telegram chat. You can do it. Okay? Since we are running out of time, we'll have to wind up now. Yes, Gautam, formula sheet also I will give you. I will send that to you on your Telegram chat. Okay, yes, Pratima, bye-bye. You're welcome, Pragnya. I hope you liked my session. This is my first session on YouTube, so if there were flaws, you can just let me know. I will, pick up on these things. So thank you. It was fun teaching you all. Thank you all. So, bye-bye. See you all in my next class.